Lesson 6.1, we're solving inequalities by addition and subtraction. You'll learn how to solve linear inequalities using addition and how to solve linear inequalities by using subtraction. How are inequalities used to describe school sports? In the 1999-2000 school year, more high schools offered girls track and field than girls volleyball. If 20 schools added girls track and field and 20 schools added girls volleyball the next year, there would still be more schools offering girls track and field than girls volleyball. That was kind of an obvious example of the addition property of inequalities. If any number is added to each side of a true inequality, the resulting inequality is also true. So symbolically, for in all numbers a, b, and c, the following are true. If a is greater than b, then a plus c is greater than b plus c. If a is less than b, then a plus c is less than b plus c. And in numbers, if 2 is less than 7, which it is, and we add 6 to both sides, 8 is still less than 13. Solve s minus 12 is greater than 65. Check your solution. So just like with equations, to undo a minus 12 in an inequality, I'm going to add 12 to both sides. And I have s is greater than 77. Now, when I do my check, I could do it the way we've always done it before and replace s with 77. 77 minus 12. And 77 minus 12 is, in fact, 65. Or I could pick a value that is, in fact, greater than 77 and make sure that it works. How about 100? 100 is bigger than 77. 100 minus 12, is it bigger than 65? Well, 100 minus 12 is 88, so yes, it is. In the book, they do 3 checks. They do the actual value, one that is in the area of where we want it to be, and one that is not. I don't feel inclined to do one that I think is going to fail. I'm going to stop there. Solve and graph on a number line. So to undo minus 9, I'm going to add 9 to both sides of the equation, and I'm basically done. 12 plus 9 is 21, is greater than or equal to y, but we prefer to write our variable first. Because then when it goes to graph, good things happen. So I have y is less than or equal to negative 21. The less than or equal to, I put a closed dot on the 21, means that it is included in the inequality. Less than, my arrow is going to the left. Now, the book is going to use set builder notation, which I'm kind of lazy about. I don't see that it gains a lot, but we should mention it. So if you see all of this business, means the same thing as what we just did, and it's read the set of all numbers, y, such that y is less than or equal to 21. I'm fine with this, and there's our graph, and we're happy. Okay, to undo plus 23, we're going to subtract 23 from both sides of the inequality. So we have q is less than negative 9. So when I go to graph it, I'm going to put an open circle on the negative 9, and arrow goes to the left. Notice again, my inequality points to the left, my arrow points to the left. The subtraction property of inequality states if any number is subtracted from each side of a true inequality, then the resulting inequality is also true. So for all numbers a, b, and c, the following are true. If a is greater than b, then a minus c is greater than b minus c. And if a is less than b, then a minus c is less than b minus c. And they have an example there where 17 is in fact greater than 8. If you subtract 5 from both sides, 12 is still greater than 3. This property is also true if less than and greater than are replaced with greater than or equal to and less than or equal to. What if they put the variable on both sides? Well, then we're going to put it on one side. So for this one, I'd want to subtract 12n from both sides of the inequality. So I have negative 12 minus 12 is no n, so I have negative 4 is less than or equal to 13n minus 12n is 1n, which we don't normally write the 1. So 1 times anything's itself, that'd be the same as negative 4 is less than or equal to n, which would be the same as n is greater than or equal to negative 4. Can you see what happened? There was a negative 4 at the small side of the inequality, and it still is here. There was an n at the big side of the inequality, and it still is here. Those are equivalent of statements, just nicer for graphing. So we want to put a closed dot on negative 4 because it can equal that, and it is greater than, so the arrow goes to the right. This is a handy chart translating our verbal expression so that we know which inequality to use. So in a word problem, if we see less than or fewer than, we're going to use a less than sign. If we see the words greater than or more than, we use a greater than sign. At most is less than or equal to. No more than is less than or equal to. Or we could just say less than or equal to. That'd be too obvious. So instead of at most, at least is greater than or equal to. Instead of no more than, if we do no less than. And of course, we could always just say it as it is, greater than or equal to, but that'd be obvious. Write an inequality for the sentence below, then solve. 7 times a number is greater than 6 times that number minus 2. Here they are breaking it down into the phrases. 7 times the number would write as 7n is greater than, 6 times that number, they wrote 6n, minus, 2. So now we get to solve. So we want to get our variable on one side. I'm going to subtract 6n from both sides of the equation. So 7n minus 6n is just 1n is greater than, the 6n's are gone. All that's left is negative 2. If I made one of my lazy graphs, I'd put an open circle on the negative 2 and arrow goes to the right for greater than. Alicia wants to buy season passes to 2 theme parks. If one season pass costs $54.99, I don't know where she's going, and Alicia has $100 to spend on passes, the second season pass must cost no more than what amount? So simplifying the problem, we see the total cost of the 2 passes must be less than or equal to $100. They chose to let S equal the cost of the second pass. So if we have the total cost is $54.99 plus S is less than or equal to $100, all we have to do to solve is subtract $54.99 from both sides of the equation. And I get S is less than or equal to $45.01. I think these are old prices. What do you think? So her second pass can't cost any more than $45.01. Summing it all up, if any number is added to each side of a true inequality, the resulting inequality is also true. If any number is subtracted from each side of a true inequality, the resulting inequality is also true.